Pose with the fans. Pose with the pose with the pose with the fans. Pose with the pose with the pose with the fans. Pose with the fans. Pose with the fans. Pose with the pose with the pose with the fans.
Assalamualaikum and a very good morning. Today we are going to present about our assignment, which is fragrance ping pong launcher. This presentation is divided into 5 parts, which is the first part is introduction. In this part, I will be explaining about the objective. The second part is design. The third part is mechanism. The fourth part is calculation, and the last part is discussion.
Okay, moving on to our objective of this assignment is to design and analyze a simple spring-powered catapult capable of launching a ping-pong ball from point A to a target point which is 1 meter away horizontally. This project integrates theoretical understanding of kinematic and kinetics with practical design, emphasizing sustainable and effective mechanical solution.
Okay, for the design, we use box as a base to make it vertically constant 0.1 to 4 meter. And then we put spring inside, close the top, and put the string inside the cylinder. Then we put the ping pong at the top.
So we're moving on to our project simulation. So before that, I will tell you guys about this. The height is 12.4 and the distance to launch is 1 meter. Okay, so here is the video that how we launch our ping pong ball.
Okay, now I want to explain the calculation part. Since we conduct the spring constant experiment, we obtained that the force versus extension have a direct proportional graph. Then from the calculation here, we get then the K value, which is spring constant is 1022.5 Newton per meter.
The result of the spring constant obtained from the experiment illustrate the direct and linear relationship between the applied load and the displacement of the system. The data points form a pattern that strongly support the Hooke's law, showing that the more force applied to the system, the more it stretches or deforms.
Before I go to the discussion about the time and the velocity, I want to calculate the angle about the launcher. Since the length of the launcher is 0.155 meter and the length and the vertical length from the ping pong to the ground is 0.124 meter, thus we obtain that the angle is around 55.13 and theta.
After that, we find the value of the time and initial velocity by applying a suitable formula. Then, we get the value of the time is 0.52 seconds and initial velocity is 3.197 meter per second. Based on the data from the theory, we apply the formula of conservation of energy when V2 is equal to 0 because the spring is uncompressed in a final state. Assume there's no energy losses, then we get the initial compression is 0.0048 meter. Our experiment showed that the spring followed Hooke's law as the force and stretch had a linear relationship. But when we tested the launcher, the real result didn't match our calculation. We expected the spring to be compressed to 0.0048 meter to reach 1 meter. But in reality, we need 0.016 meter. The difference was likely due to friction in the launcher and resistance on the ping pong ball and the small measurement errors.
In conclusion, our project was successful, which is the spring can launch the ping pong into the target 2
that 1 meter length, the distance of 1 meter.